This comes out of section 4.3, the first derivative test. So we're asked here to find any max min of this function, f of x equals 2x minus 3x to the 2/3. I could have also said find the critical numbers, find the intervals of increase, decrease, and then find the max min, but really we would do hopefully that anyway. Find the derivative f prime equals 2 minus 3 times 2/3 is 2x to the negative 1 over 3. Now looking at it just like that makes it a little bit hard to picture the factoring. We saw something like this way back earlier in the course, and we used a little trick here to say picture this as 2x to the 0 minus 2x to the negative 1/3. Now x to the 0 is just 1 anyway, but it allows me to say, okay, well, my common factor here, take out this, and that will leave me with x to the 1/3 minus 1. Kind of a artificial almost way of factoring. Still is true, it does work. If you multiply it out, you'll get 2x to the 0 minus 2x to the negative 1/3. But I find that my critical numbers are x equals 0, because if I put 0 in there, this first term would give me undefined, and x equals 1, because if I tried solving when does x to the 1/3 minus 1 equals 0, it's when x to the 1/3 equals 1, which is when x equals 1 cubed, which is just 1 if you cube both sides. So I've got one spot where the derivative is undefined, and one spot where the derivative is 0. But either way, they are both critical numbers. So when I look to find intervals of increase or decrease, I look to the left of, to the right of, and in between. So if we look at this further, a number to the left of 0, any negative number, if you put it into this derivative, you're going to get a negative times a negative, which will give you positive. So this function is increasing everywhere to the left here. Put in a number in between, and that one might be a little bit harder. You might want to actually pick a number 0.5 and put it in there, but you'll get a positive value out in front, and you'll get a negative value inside. So positive times negative is going to give you a negative. So this function is increasing and then decreasing, which means we have a max at x equals 0. It so happens if you put that into the original function that the point is also, it's at 0, 0. The value of the function is 0. Now if I put a number to the right of 1 into the derivative, 2 or 10 or 1,000, and I have a positive times a positive, so the function starts to climb again, which tells me that I must have a minimum at x equals 1. And if I put in x equals 1 there, I get that y equals negative 1. So you have at the point 1, negative 1, you have yourself a minimum. Notice this question is a little bit unusual in that we had a place where the first derivative was undefined, but it still turned out to be a maximum, and a place where the first derivative was 0, and it turned out to be a minimum. That just happens to be the characteristics of this particular strange function. If you really want to see what this function looks like, graph it on a graphing calculator, and it has kind of a cusp or a point at the origin that you can't draw a tangent, but it is a max.